All right, so welcome back. Welcome back to this channel. So in the last video, we have looked at video generation, right? We have finished that series. In this video, we are going to redirect ourselves back into like normal machine learning development. I think we have gone far into ML research, deep learning research, or machine learning research. Right? We have been covering a lot of models, a lot of techniques to like building a model, like all the model code and all the model intuitions and of different models in different fields. And we have, I think I have also provided you and empowered you to read your own, to read research papers by your own. We have walked through some research papers, and you could I have shown you that you don't have to go through all of that things that have been stated. And yeah, we have looked at research. Yes, we have learned about model development, but it turns out that there is a bigger piece of the puzzle that you have missed. There is a bigger um, there's a bigger component in machine learning software engineering, building machine learning models in the real time, in the real situation. There is a big concept, a big thing that we need, right? That we have missed. Uh, that we have missed. Like model development is not the only main thing. Right? Until now, we have developed models to perform beautiful, amazing tasks and wonderful tasks, and that is very research oriented. But we should make sure that um, we are also equipped with the knowledge to build applications for the real time that that are actually very useful, and we could actually update them and like solve all the problems that are related to the practical life of users. you know like I think there is a lot of research, right? There is a lot of research and very less products. I think um, the like research is going on, so much research is going on, but the products are like using very old research. Very new research is actually going on, and a lot of research that is going on currently is actually not that useful for the practical life, for the real life. And MLOps comes in between to make us build these models and distribute them and serve them correctly to users. That is actually production, machine learning production. We'll be covering that uh, through the span of this channel. I'll probably put in some like research paper readers also in the middle, and also we'll try to cover up some more things as we go on. So the first thing to actually learn what is MLOps. Even I am also that not that good with MLOps. I think I also have to sharpen up my skills in like production or serving ML systems, right? So first thing, obvious thing, I have gone to ChatGPT and just type like what is MLOps, and you might have heard of the term DevOps if you are into like learn, or if you have read a lot about software engineering, or yeah, if you have read a lot about software engineering, you might have uh, like come across the term DevOps. We'll be covering that also. I have searched what is MLOps. So this is the definition, or this is the thing that we have got from the ChatGPT. So MLOps stands for machine learning operations, and it refers to the practices and techniques used to streamline and optimize development, management, monitoring, and maintenance of machine learning models in production environments. It's an extension of the concept of DevOps, development operations, applied specifically to machine learning workflows. The main goals of MLOps, the main goals of MLOps are to increase the efficiency, reliability, and scalability of machine learning systems while ensuring that ML models are continuously updated and improved. And this is a very good point, and I'll also show you with an example in just a minute. So, MLOps encompasses various stages and processes in machine learning lifecycle. Data management, proper data collection, processing, and storage are crucial for ML model success. MLOps involves establishing robust data pipelines and version control systems to manage data efficiently. Right, data management, managing data, model training, um, ensure the model training is repeatable and automated. Right, it is repeatable, and we could train the model again and again on new data. And model development, so deployment, right? I think this is like deploying on some systems, I believe, using some technologies. I have to go through that. Monitor and logging, continuous monitoring of deployed models is essential to identify potential issues or performance degradation. MLOps sets up logging and monitoring systems to track model performance and ensure timely alerts for anomalies. Continuous integration and continuous deployment, CI/CD pipelines. MLOps practices include integrating ML flows into CI/CD pipelines, model versioning, government supply. So essentially, we have got like some points, the main goals. The main thing is, for example, let's say you are working in a vegetable company, something that maybe like for probably Reliance in India. Maybe you are working in some like companies like that, in which you have to like sell vegetables, right? You buy them for low prices and sell them. So let's say let's say you are selling tomatoes, right? You are selling tomatoes, right? You are selling tomatoes. So while selling, while actually storing them in boxes, and maybe you have some carriers, right? No, some type of elevators or something that will just move and with boxes of this, right? And you will have, and what we'll do is you have to take a picture. We have to take a picture of all the tomatoes and make sure that no tomato is spoiled, right? You want to make sure that every tomato in that specific box is actually pretty good. So for that, rather than hiring another human, right? Rather than hiring a human and paying him a lot of money and make like hiring a lot of humans, and also affording many inaccuracies, right? You have to afford inaccuracy. If you hire a human, he might make a lot of inaccuracies, not detecting the spoiled ones, because he will be working for a lot of time. Human will get um, out of patience and maybe do some mistakes. So you can use a machine learning model, right? You can train a machine learning model. You could train a machine learning model using a simple, probably a image classification model or object detection model. And then what you could do is you could just for example, this tomato is spoiled, right? You want the model to actually predict this bounding box, and maybe can have a hand, right? A robotic hand, and maybe get the coordinates of that specific tomato and get that hand and pick it up and throw it down, right? Maybe something like that, some type of architecture like that. So what you want is you want the model to take this image. For example, this is an image, right? As the carrier goes on elevator, you will take that image. So it stops at a particular point. You take that image, right? And you send that to a backend or ML model. You send that to an ML model, and the model will send you some results. Like if that can is full of good tomatoes or not, maybe get that check, and then check if any tomato is actually spoiled or not, and then you do that, right? So this is the idea. So if you have developed this ML model, the idea of MLOps is actually basically able to use it on real time, such that we could actually interact very fastly, such that let's say having multiple systems built around it and performing tasks like very good. And one problem that we might face in this scenario is that, for example, over the first 6 months you have built the system, and over the first 6 months it worked very well, right? You have detected many spoiled tomatoes and all that. And what if, right? What if suddenly maybe the lighting changes, right? Maybe in the lighting of the shop, right? You have that um, factory. Maybe the lighting of the factory changes. Maybe you have yellow lights rather than red lights or white lights. Maybe you have different types of lights, or maybe you have different types of basket colors. Maybe you want maybe different types of shapes of these baskets. Maybe these baskets are made of different shapes, or maybe the lighting is very different, right? The data will turn, right? Then there is a chance of data changing its uh, distribution. For example, in the training data set, while you're training the model, all the images are shoot under white light. And then if all images are shoot under white light, and when the double, like when deployment, for example, once the lights are changed to yellow color, maybe that will uh, in, uh, influence the results, not by a lot, but even a slight amount. Then that will cause our model to fail, right? Then that will cause our model to fail. Then we could use MLOps to able to train our model simultaneously. So rather than just inferencing, yes, we during inference, as we are outputting the results, we could, right, when the model is actually, if the model actually if the environment changes, right, if the environment in which the images are taking changes, we could hire one employee and basically teach the model as we go on. So as for example the lighting changes, then we could actually hire a part-time employee or freelance work or something like that, and maybe pick him, maybe let him pick the spoiled like tomato, and the model learns in different environments. And this is the idea of MLOps. So being able to train the model as we go on in the inference time. So whenever necessary, we could retrain the model. So that is, I think, one feature of MLOps. And this is actually very good use, right? And then also data management, proper data collection, pre-processing, and storage are crucial for ML model success. MLOps involves establishing robust data pipelines and version control systems to manage data efficiently. Just as I said, we could change the data as we go on. So, for example, in the first phase, or maybe previously we have different type of data, and as we go on, we update the data set such that we make the model more more suited to different environments, or the environment that we're currently want our model to perform, right? And then monitoring and logging. So as we are going on, we want to monitor model performance and make sure that we evaluate it now and then, right? Right. And then also we want to like we want to automatically test the model, and after updating every model, so after training every new model, you want to deploy it, deploy the newer model, and also like many things, right? So we want to make sure the model is updated. We want to validate the model now and then. So to do that, we want to validate the model very fastly, and we want to collect our data. We want to change the data set, and to do all of these tasks, we'll build some type of systems around this. And that is the art of building MLOps, machine learning operations, to be actually able to build systems that are able to do this task for us, to do data management, to like retrain our model whenever necessary, to validate our model whenever necessary. So that is the idea of MLOps. So like this video is just for the introduction to MLOps. As we go on, we'll be covering some more concepts in a little depth. As we go on, we'll be doing more and more. So DevOps is also a set of practices that combine software development and information technology to foster collaborations and streamline the software development cycle. So that's essentially, I think, MLOps is like DevOps to machine learning, right? So we'll be essentially, having to change this software as soon as possible whenever necessary, to be able to perform tests and all that. So we want to build a system around this, right? So that is machine learning operations, or machine learning in production, right? So that's it for this video. I want to make this as small and clear as possible. So yeah, thanks for watching. I'll see you in the next one.